interesting study examined the temperature elevation at electrical receptacle screw terminals. The study used 120-volt, 15-amp receptacles and copper wire. The primary focus was to determine how torque and wire contact area affected the temperature at these terminals. Torque was adjusted on both the hot and neutral terminals. The range explored was from 0-inch pounds to 12-inch pounds. The apparent wire contact at the screw terminal was also modified. Two different lengths were tested, 1/8 of an inch and 5/8 of an inch. The research team did not find any significant difference in temperature when the apparent wire contact was changed. However, they did observe increased temperatures when the torque was reduced. It is important to note that even with reduced torque, the temperatures weren't high enough to start a glowing connection or cause rapid oxidation. Further investigation revealed a critical factor. Movement of a loose connection was necessary to cause substantial temperature changes. This movement was also linked to arcing, sparking, and rapid oxidation. In some instances, it even led to glowing connections. To summarize the findings, changing the apparent wire contact area, specifically comparing 1/8 of an inch to 5/8 of an inch, did not significantly impact the temperature at the receptacle screw terminals. Increasing the torque applied to both the hot and neutral terminals resulted in lower temperatures. This aligns with best practices for electrical connections. While reducing the torque did lead to increased temperatures, these increases were not significant enough to immediately cause dangerous conditions such as glowing connections or rapid oxidation. The key takeaway is that movement of a loose connection is the primary driver of significant temperature changes, arcing, sparking, rapid oxidation, and in some cases, glowing connections. The study suggests that achieving proper torque is important for secure electrical connections. However, varying the exposed wire contact area within the tested range does not significantly impact temperature elevation. While loose connections pose a risk of overheating, arcing, and sparking, these conditions are unlikely to occur without movement of the connection. This underscores the importance of secure connections that won't easily loosen or move. Considering these results in practical applications, electricians and anyone working with electrical wiring should focus on ensuring connections are properly tightened to the manufacturer's specified torque. While the length of exposed wire within the tested range appears to be less critical, it's still important to follow best practices for wire stripping and connection to minimize the risk of shorts or other issues. The emphasis should be on preventing loose connections and ensuring that any connections made are secure and unlikely to move or vibrate over time. For example, in residential wiring, receptacles are subject to vibration from regular use, such as plugging and unplugging devices. In industrial settings, machinery can create vibrations that could affect electrical connections. Therefore, proper torque and secure connections are crucial in both environments. The National Electrical Code, or NEC, provides guidelines for electrical installations and connections. While this study doesn't directly reference specific NEC sections, it reinforces the importance of following NEC guidelines related to proper wiring methods, connection techniques, and torque requirements. Always consult the latest edition of the NEC and any applicable local codes for specific requirements in your area. It is also important to remember that this study focused on 120-volt, 15-amp receptacles and copper wire. The results may not be directly applicable to other types of receptacles, wiring materials, or voltage levels. For example, high voltage or high current circuits may exhibit different behavior. Different wiring materials, such as aluminum wire, have different properties and may require different connection techniques and torque specifications. Aluminum wiring, for instance, expands and contracts more than copper, which can lead to loosening of connections over time if not properly installed. Therefore, it's crucial to understand the specific requirements for the wiring materials and equipment being used. The study highlights the importance of ongoing maintenance and inspection of electrical connections. Even if connections are initially properly torqued, they can loosen over time due to vibration, thermal cycling, or other factors. Regular inspection and retorquing of connections can help prevent overheating, arcing, and other potential hazards. This is particularly important in critical applications where electrical failures could have significant consequences. For example, in data centers, hospitals, or industrial facilities, regular electrical maintenance is essential to ensure reliable operation. Furthermore, the study underscores the importance of proper training and education for anyone working with electrical wiring. Understanding the principles of electrical connections, proper torque techniques, and the potential hazards of loose connections is crucial for safe and reliable electrical installations. Electricians and other electrical workers should receive comprehensive training and stay up to date on the latest codes and best practices. The use of torque screwdrivers or torque wrenches is recommended to ensure that connections are tightened to the manufacturer's specified torque. These tools provide a more accurate and consistent way to tighten connections compared to relying on feel alone. Torque screwdrivers and wrenches are available in various sizes and torque ranges to accommodate different types of electrical connections. When using these tools, it's important to follow the manufacturer's instructions and to calibrate the tools regularly to ensure accuracy. In addition to proper torque, the quality of the electrical connectors themselves is also important. Using high-quality connectors that are specifically designed for the type of wire and equipment being used can help ensure a reliable and long-lasting connection. Avoid using counterfeit or substandard connectors, as these may not meet safety standards and could lead to connection failures. When making connections, it's also important to avoid overstripping the wire. Exposing too much bare wire can increase the risk of shorts or ground faults. Only strip enough insulation to allow for a proper connection within the connector. Follow the manufacturer's recommendations for strip length. Similarly, avoid nicking or damaging the wire insulation during stripping. Damaged insulation can weaken the wire and increase the risk of electrical hazards. Use a proper wire stripper that is designed for the size and type of wire being used. Before making any electrical connections, always de-energize the circuit. This means turning off the power at the circuit breaker or fuse box. Use a voltage tester to verify that the circuit is de-energized before touching any wires or terminals. This is a critical safety precaution that can prevent electric shock. When working on electrical systems, always wear appropriate personal protective equipment, including safety glasses, gloves, and insulated tools. This equipment can help protect you from electrical hazards such as arc flash and electric shock. Arc flash is a dangerous phenomenon that can occur when a short circuit or other electrical fault creates a high energy explosion. Arc flash can cause severe burns, blindness, and even death. Insulated tools are designed to protect you from electric shock by providing a non-conductive barrier between you and the energized circuit. In conclusion, this study provides valuable insights into the factors that affect temperature elevation at electrical receptacle screw terminals. While wire contact area appears to be less critical within the tested range, proper torque is essential for secure and reliable connections. Movement of loose connections is the primary driver of overheating, arcing, and sparking. Following best practices for electrical wiring, including proper torque techniques, using high-quality connectors, and regular inspection and maintenance can help prevent electrical hazards and ensure safe and reliable electrical systems.